number. So the range 1 to 64,511 are globally unique AS number. So globally unique AS number means these are the public AS number 1 to 64,151. Sorry, 64,511. And range between 64,501 to 65,535 are private autonomous system number. So on BGP have two flavors, external BGP, internal BGP. So external BGP means we can communicate between the autonomous system number. Internal BGP means we can communicate within an AS number. So the external BGP, internal BGP, so we will discuss separate video session. So this is just introduction to BGP. So that's why I'm covering just overview of all the concepts. Okay, next one, BGP advertisements. So internet is a big place. There are more than 5 lakhs of routing entries are there. Networks are there. Complete internet routing table. This is not accurate value. Is a more than 5 lakhs. Okay. So if you want to check the internet routing table in your own network, so if you want to see your network means you have to give show IP route. So you can see what are the networks we can learn. So maybe 10, 20 or 30, maybe 200, 500, so within 1,000. But internet routing table have connecting all over the world, so they have more than 5 lakhs entries are there. So go to this website, you can check each and every day they will update the internet routing table entries. And also one more website is there, BGP4.as, looking-glass. So go to this website, there are some servers are there, public servers are there, so we can use show IP BGP to see the routing table entry, internet routing table entry. So only show command only it will be applicable for just for study purpose, it will be there. So just go to that website and go through it. Okay, so BGP advertisement. So when we run BGP, does this mean we have to learn more than 5 lakhs prefix? So here what I'm saying means, in case I am the customer, I connected to one ISP. In my side I'm using BGP routing protocol. So should I learn all the complete entire routing table to learn from the ISP? So here no. There are some option is there. So we can take this example scenario. This is customer network, AS number is 10.0.0.0/8 and ISP1 AS number is 2 and network is 20.0.0.0/8 and ISP2 AS number 3 and network is 30.0.0.8. okay. So in our picture, our customer network has an autonomous system number AS number 1 and some IP address space. Let's pretend that these are the public IP address range. Okay, consider this is a private range. Just consider as a public range for an example. So we are connected to two different ISPs and you can see that AS number 2 and 3 and IP address space are 20.0.0.0/8 and 30.0.0.0/8. So we can reach the rest of the internet through both ISPs. Okay, so we can use BGP. So if I'm using BGP to advertise my network to the ISP1 as well as ISP2, so advertise our address space to the ISPs. But what are the ISPs going to advertise our customer through BGP? So as a customer, I am advertising my public network, my network to ISP1 as well as ISP2 through BGP. So what about the return traffic from the ISP to the customer? Either they will advertise all the routing table. So that's my question. So there are number of options are there. So first one, ISP will advertise only default route to the customer. That is the first option. Second option, they will advertise default route plus partial routing table. And third option is full internet routing table. We can see. So first one is a default route. So if the ISP is advertising the default route means it will be good. So we have only one entry, so we can reach the ISP. Then ISP is responsible to reach the internet. And also in customer end, we don't know behind the ISPs. Okay, so if you are using ISP, there is one problem. suboptimal problem. So what that means in case the customer 1 can learn the default route through the BGP from ISP1 as well as ISP2. Consider ISP1 as a primary. Now the customer wants to reach the 30 series network. So the customer is directly connected to ISP1 as well as ISP2. But the customer will goes to ISP1. From that ISP1 it will goes to ISP2. So that is an suboptimal problem. So our customer network only received a default route from the both ISPs. So what I explained, I given in that point. So we have chosen to use default route of ISP1 to send all our outgoing traffic to. So this means that whenever we send traffic mean for 30 series network ISP2, it's going to be sent to ISP1 and then to ISP2. It is not a problem, but it is an not optimal. This is not an optimal. Okay, second one is an partial routing update. So in partial routing update means the ISP will advertise default network plus the ISP assign the IP address to their client. That network also they will advertise to the customer. So it will reduce that suboptimal problem while we are seeing in the default route advertising. So it will going via customer ISP1 from ISP1 to ISP2. This will be avoided if they are advertising partial plus default route. Partial update means the ISP will assign the public IP address to the customer. So that network only advertise to the customer. So next one is a full internet routing table. So full internet routing table means, for example, more than 5 lakh prefix are there means complete routing table will be advertised to the customer. But this is not a good idea because in home based, in customer based router we should have high-fi configuration, because minimum we have 512 MB of RAM, then only we can run BGP protocol. So there are some hardware issues also there, and if the more than 5 lakhs prefix if you are received means the router automatically goes down, fully hanged, high CPU utilization. So there are a lot of criteria are there. So based upon that we have to receive full routing table. So same like our configuration should high if you want to reach full routing table, internet routing table. Okay, so next one, path vector. So this is an example scenario. For an example, in AS4, so this is a different autonomous system number. From this router, if I learn the 1.1.1.0/24 network from AS1, so we have 4 autonomous system and we are running BGP. So we are running BGP, exchanging routing information between the AS number. So in AS1 we have a network 1.1.1.0/24 network, and this is advertised to AS2, AS3 and AS4. So if we would look at the BGP table of the router in AS4, then we will see the network entry. So we can log in into the AS number 4 in this router and give show IP BGP. Then we can see the network. We can learn 1.1.1.0/24 network from AS1, but it also stores the path. So not only the network entry it stored, it will store the next hop IP as well as the path vector. Path vector means through which AS number we will reach. So they will mention 3, 2, 1. That is a path vector. So but it also stores the path. We have to get through it in order to get there. So it will store the prefix but also the path it has to cross in order to get the 1.1.0/24. Here is an example for real BGP router. So this output I taken from that BGP looking glass. So I show it that link. From that link, this is a public server. This is a public router. We can, using this router, we can log in and we can check the show IP BGP and show IP BGP summary. So here we can see I will give show IP BGP I learn 1.0.0.0/24 network. So here we can see path. So we can go to 7473. From that 7473 we can go to 15169 to reach that network. So that's why is a path vector. So more deep we can see in different video session. Okay, next one, BGP route selection. How the BGP will select the route selection. So what all the IGPs have in common is that all of them want to find the shortest path to the destination. So Interior Gateway Protocol in common, all of them are wants to find the shortest path to the destination. That is the Interior Gateway Protocol working principles. But in BGP works differently, since autonomous systems belongs to different ISP or organization. Because if you are running BGP means you have own autonomous system number, and if the large organization, they are using different AS number, and ISP also they can use different AS number. Okay, so we want to be able to selectively influence our routing. So for an example, here we can see R1 router. So each and every circle is an individual AS number considered as a one large organization and ISP, something like that. So AS number 1, 2, 3, 4, 5, 6, 7, 8. So from R1 router, this AS number 1, I want to learn the network 192.168.100.0/24. This is comes under AS number 8. So either I will reach R1 to R2 or R1 to R5. So from R2, either they will go R6 or R3. So BGP allows us to use routing policies at the autonomous system level. In the picture above, I have 8 autonomous systems, and in AS8 we have a network 192.168.100.0/24 network. If we look at AS1, then we have a lot of different paths we can take to reach the network 192.168.100.0/24 in AS8. Okay, does this mean that network administrator at the AS1 can choose the path we are going to use? Not really, because of the following reason. So what I'm saying means, in AS number 1, the network administrator can choose the path, which path we have to reach the AS number 8. So we can't do these things. We can see, you can choose the exit path. AS1 can send traffic to AS2 or AS4, but you don't make routing decision for other autonomous system. So this is my autonomous system number AS1. So I am the network administrator for this autonomous system. So I want to reach 192.168.100.0/24 network from AS8. So I will choose the exit path. That only one thing, that rights only I have. Either I will go via R2 or R5. That's it. In case if I select R2, then afterwards R2 only decide how to reach autonomous system number 8. Either they will go via AS3 or AS6. So I don't have any rights to make any routing decision for AS2 or AS5. So only rights for me is to select the exit path. Either we can go via AS number 5 or 2. So that's thing only I'm saying here. Okay, so you can choose the exit path. AS1 can send traffic to AS2 or AS4, but you don't make routing decision for other autonomous system. So each autonomous system will only advertise the best path to your autonomous system. So either R2 as well as R5 will advertise only the best path to our autonomous system. We'll consider like AS number 1. So AS1 will only learn about the best path from AS2 and AS4. So AS5, so this is a typo error. This is AS5. Unless the best path fails, so only then you will learn about the second best path. So your neighboring AS number, either AS number 2 or AS number 5, will advertise only the best path to your autonomous system. So based upon that, you can select the path, exit path. So next point, BGP use set of BGP attributes to select the path. So in BGP, in Interior Gateway Protocol, they are using different metric values to find out the shortest path. But in Border Gateway Protocol, they are using some set of attributes. Using that attributes, they will select the path. So these are the things we can discuss separate topic in upcoming videos. So this is the first video for BGP course for introduction to the BGP. So that's why in this video session I will cover why we need BGP and where we can use BGP, what is meant by AS number, so how the BGP will advertise the routes, so how the BGP will select the route selection and path vector. So everything I will cover in this video session, in this video tutorial in introduction to BGP. So in case if you have any queries, so you can comment in that below comment section. I will reply to your query. Okay friends, thank you for watching my video. So this is my 200th video, so thanks for your support, and if you have any queries, please ping me. I will reply to your query, and subscribe my channel for further updates. So my channel name is Gowthamraj F. In the channel I created separate playlist for BGP. In that BGP playlist you can see all the video session, so I will upload daily basis, so you can go through in that order. So you have go through that concept and do practice. Okay friends, thank you for watching my video.